Here we're going to talk about the binomial coefficient, which is on page 183. First of all, it just goes through and makes sure that you remember what a factorial is. Factorial is always an integer exclamation point, and what that means is count down from that positive integer down to 1 and multiply all the numbers between that number and 1. For example, 6 factorial is equal to 6 times 5 times 4 times 3 times 2 times 1, which is the same as saying, I wrote messy there, this would be 30 times 4, which would be 120, times 3, which would be 360, times 2 is 720, it would be 720. Okay? How to do factorials on the calculator. Basically, to do the factorial on the calculator, all you need to do is put in the 6, for example, if you're going to do 6 factorial, and then you go to the math menu, and then you go to the PRB. I think it means probability or something. And then you go to NCR, I'm sorry, not NCR, you go to the exclamation point. So 6 exclamation point is 720. We verified my manual calculation there. Okay, so this procedure here is just telling you how to do that. 0 factorial. 0 factorial is actually the same thing as 1 factorial, which just means it's 1. If you forget that, then you could just use your calculator on the test if it's a calculator problem. If it's not, you will see that 0 in most cases makes no sense for these formulas. Okay, let's go back here for a second. Okay, so 0 factorial is equal to 1. Express the binomial coefficient as factorials of n and r. And if you look in the book, the formula for the binomial coefficient is it's equal to n factorial on the numerator, and then in the denominator you have n minus 1, or n minus r, quantity factorial, and r factorial. And you can write that in a few different ways. One of them is in the parentheses like this with the n above and the r below. The other way you could write it is like that, or even like that. Okay? But the formula is this. And the way you would do that on the calculator, you don't have to type all that in. You can actually use a math function here. And the way you would do it is, like, let's say that we're going to do n equals 8, r equals 5. The way we do that was first we type in 8, and then we go into math, and then we'll go to PRB, and then we'll go to NCR, and then we'll put in 5. Okay, and that'll give us 56, which happens to be 8 factorial divided by 5 factorial, also divided by 8 minus 5 factorial, which is the same thing as 3 factorial. Okay? Okay, now we're going to go back to the problems here, most of which you don't use a calculator. Find n factorial for 0, 1, 2, 3, all the way to 6. So 0 factorial, remember, is 1. 1 factorial is also 1. 2 factorial is 2 times 1, which is just 2. 3 factorial is 3 times 2 times 1, which is 6. 4 factorial, it would be just 3 factorial times 4, which is 24. 5 factorial would be 5 times 4 factorial, which would just be about 120. And then 6 factorial would be 720, like we found above. Simplify without using a calculator. This might look like you need a calculator, but actually if you write it out, you will see that you don't. Because when you have 6 factorial over 4 factorial, you can see that a lot of these numbers cancel out. What you're left with is just 6 times 5, which is 30. Right? So the numbers that extend beyond the denominator's factorial are the ones that are left. So for example, 100 factorial over 99 factorial, you would basically just have 100 left, right? On the bottom you have 99 times 98 times all the way to times 1, and so these would all cancel out, right? So you're just left with 100. For this one here, you would have 7 factorial divided by 5 factorial. That's just 7 times 6, because the 5 times 4 times 3 times 2 times 1 is divided out by the 5 factorial, divided by 2. So that's equal to 42 divided by 2, which is 21. Number 3, simplify these. Well, n factorial divided by n minus 1 factorial is just n, right? Because n is n times n minus 1 times n minus 2. N minus 1 factorial deletes, cancels out everything except for the n. N plus 2 factorial over n is just equal to n plus 2 times n plus 1. And that's it. Okay. 4. We're going to do A and C only. Use the formula to evaluate. And so we'll just put 3 factorial over 1 factorial times 3 minus 1 factorial. And that's just 1. And this is equal to 2 factorial. 3 divided by 2 factorial is just 3. Let's see, and what about the 7? So this is equal to 3 factorial, 7 minus 3 factorial. So it's equal to 7 factorial divided by 3 factorial divided by 7 minus 3 factorial, which is 4 factorial. Okay? So that's equal to, let's see, 4 times 3 times 2, so the 4's cancel out. 3 times 2, the 6 cancels out, and we get 35. Okay? And then the last problem. Use the formula, and R equals, to evaluate. Okay. And so, for example, this one, it would be 8 factorial divided by 2 factorial, 8 minus 2 factorial, which is 6 factorial. So that would be equal to 8 times 7 divided by 2, which is equal to 4 times 7 equals 28. Okay, can you explain these results using Pascal's triangle? Oh, wait, by the way, we haven't done this one yet. This would be 8 factorial divided by, actually, it looks exactly the same, doesn't it? Also gives me 28. Can you explain these results using Pascal's triangle? Actually, like what you see here is that the third term of the 8th row of Pascal's triangle is going to be, well, let's see, let's do one we know. Let's see, we know the 5 one by heart, right? And then we'll just do the 6 one. And then we'll do the 7th one. And then we'll start doing the 8th one. So that 1, 8, 28, blah, 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 blah. And then at the end, it ends with 28, 28, 8, 1. So can you explain these results using Pascal's triangle? Yes, because 8 over 2 here gives us this coefficient. And 8 over 6 here gives us this coefficient. Okay? The first coefficient is given by 8 over 0. The second coefficient is given by 8 over 1. The third coefficient is given by 8 over 2. Okay? And then the third to last one is given by 8 over 6. Okay? The reason why they're the same is because Pascal's triangle is symmetrical. Okay?